Hello, hello, hello. Good day once again, everyone. We are going to discuss another problem here. This is in continuation with the projectile topic. So the first, which I have presented you are the concepts or the fundamental concepts. This time we are going to we are going to solve problem involving projectile motion. So according to the problem, we have a projectile which was fired with or is fired with an initial speed of 196 meter per second with an angle of 30 degrees above the horizontal from the top of a cliff which is 98 meters high. So we have a projectile fired with an initial speed of 196 meters per second at an angle of 30 degrees above the horizontal from the top of a cliff, which is 98 meters high. So the first question is, what is the time to reach the maximum height? That is the first question. The second question, what is the maximum height above the base of a cliff? Third question is, what is the total time in the air? And the last question, what is the horizontal range of the projectile? So the first question is about time. Second question is about height, maximum height. The third question is about the total time in the air of the projectile. And the last question is the horizontal range of the projectile. So if we are going to draw the figure based on the problem, this is the most probable diagram for the figure. So according to the problem, initially the projectile is fired with a velocity of 196 meter per second. So this was fired at a certain 30 degrees with the horizontal. And the height of the cliff, those are the given data, the height of the cliff, including the height of the cliff, which is 98 meters. So the first question is the time to reach the maximum height. So if you would notice, this is the maximum height that can be reached by the projectile. And at that particular moment, the velocity of the projectile will be equal to 0. So that's the first condition. So if you are going to determine, if we are going to determine the first question, what about the time to reach? Okay, so if we are going to solve for the time to reach, okay, so the time to reach the maximum height, okay, so remember that the velocity at maximum height will be equals to 0. Okay. So since the velocity at that particular instance is equals to 0, then we can just make use of the formula, okay, by trigonometric function, because we have a 30-degree angle for the projectile at an initial velocity. Let's say this is initial velocity is 196 meter per second. Sorry, that's the initial velocity, which is 196 meter per second. So that was fired at a certain angle. So that means if we are going to look for the initial velocity, that would be equal to 196, okay, sine of 30 degrees. Okay, so that is opposite over hypotenuse. So we are looking for this vertical component. Okay, so for the initial velocity v sub 1, that was 98 meter per second. Okay, and if you are going to look for the final velocity, that is simply equals to, from the formula of physics, initial velocity plus acceleration times time. So for the final velocity, because at maximum height, the final velocity is equals to 0, that would be equals to the initial velocity, which is actually the one we have computed, that is 98 meter per second, plus, of course, we have the acceleration due to gravity because at that particular point, the tendency of the projectile is to go down. So initially, our acceleration we are going to consider is the acceleration due to gravity, which is a -1, that's going down. And then you multiply it by the time, which is the one which is in question. So if you are going to determine the value of the time, that's basically 9.81 times t is equals to 98. And then that would mean the time it would require for the projectile to reach the maximum height, which is equals to 10 seconds. And that will be our answer for the first question. Okay, so the time to reach the maximum height is actually 10 seconds. Again, take note that at maximum height, the velocity will be equals to 0. Okay, so we equated the final velocity is equals to initial velocity plus AT with 0. Then according to the second question, we need to determine the maximum height. So meaning what is the maximum height that can be reached by the projectile. So we have a 98-meter height of the clip. We add up this h, which was the height reached by the projectile. So the maximum height that we can have will be equals to, using the formula for the velocity in final velocity squared is equals to initial velocity squared minus 2 times g, which is acceleration due to gravity, multiplied by h. So take note that based on our computation, since v sub 2 is at the maximum height, so that would be equated to 0. And that would be equals to, based on our computation, the value for the initial velocity that we computed, that is VA previously, V sub 1 is equal, V sub 2 is equals to V sub 1 plus 80. So we computed the value for V sub 1, which is 98. That was taken from 196 sine of 90 degrees. So we are going to use 98 squared minus 2 times the acceleration due to gravity, which is 9.81. Then we have the unknown, which is the value for the h, the height of the projectile. So we have 98 squared is equals to 2 times 9.81 times h, and h therefore is equals to 489.5 meters. So that means the maximum height that can be reached by the projectile is 489.5 meters, plus of course we have the 98 meters. So the maximum height is equals to 587.5 meters. This will be our answer for question number 2. That is the maximum height that can be reached by the projectile. So we are down to the third question for this problem. Now, the third question is about the total time in the air. Okay, so the total time in the air for the projectile can be determined using the formula for the value of y. Okay, so y is equals to initial velocity, which is the y component, multiplied by time, plus 1/2 a t squared. So in this particular case, the value of y here that we are going to use is negative 98, okay, which going down the cliff, that which is basically the height of the cliff. So we have 98 is equals to, and then of course you have the initial velocity, which we computed a while ago, which is also 98. The value is 98. That was taken from 196 meter per second, a sine of 30 degrees, which is 98. Okay, so the y component of the initial velocity multiplied by the time, which is the one in question, plus, of course, you have 1/2, and because we have acceleration due to gravity, but take note, we are going to use a -1 because the projectile is going down already. And then you have the time it would take for the projectile in the air, that is t squared. And that means we will be able to determine the value for the time, which is equals to 21 seconds. So this is our answer for question number 3. That is the total time required, or the total time it would take for the projectile to be in the air. And the last question is the value for the x, which is the horizontal range of the projectile. So given the formula for the horizontal range of the projectile, okay, let's use that as our answer for question, as our formula to answer question number 4. That is the horizontal range of the projectile. The horizontal range of the projectile can be determined, okay, let me just write down. Horizontal range of the projectile can be determined using the formula for x. That is the horizontal range. We are going to use the x component of the initial velocity multiplied by time, plus we are going to use 1/2 acceleration times t squared. So x is equals to, initial velocity is 196. Remember that we did make use of sine 30 degrees a while ago to determine the initial velocity y component. So this time we are going to use cosine of 30 degrees for the x component of velocity. And then of course, we don't know yet the time, plus of course you have 1/2. The acceleration initially is 0. Okay, so initially is 0. That is horizontally. And then you have the value for the time, which is the one in question. So therefore, we will be able to determine the value for x. And upon calculation, it will give us to a value of 3,564.56 meters. So that is the total horizontal range. So there you go, ladies and gentlemen. This is Dr. Ramela B. Ramirez at your service. I shall see you in my next video tutorial. God bless everyone.